Welcome back to Street Talk. Today we are speaking with Mark Saroufim. He recently wrote an article called Machine Learning, the Great Stagnation. Machine learning PhD students are the new investment banking analysts. Both seek optionality in their career choices, but differ in superficial ways, like preferring meditation over parties and marijuana and Adderall over alcohol and cocaine. A machine learning PhD is now just an extended interview for FANG, which is Facebook and Google and Microsoft, etc. The entire data science interview process at larger labs has become a mix of trivia and prestige. Checking out a portfolio takes way too long, but checking that you graduated from Stanford or co-authored a paper with Google Brain, now that is a filter. He often gets asked by young students that are new to deep learning, what do they need to know, from a mathematical point of view, and his answer is matrix multiplication and derivatives of square functions. All these neuron analogies, according to Mark, do more harm than good in explaining how machine learning actually works. Wait, so you're telling me it's all matrix multiplication? Always has been. He says he's learned the hard way that deep learning is an empirical field. So why or how something works is often more anecdotal as opposed to theoretical. He says that the best people in these empirical fields are typically those who have accumulated the biggest set of experiences, spending lots of time doing it and getting really good at running many concurrent experiments. Age is a proxy for experience, according to Mark. If you and all your peers have access to data centers, this is yet another multiplicative feedback loop, since you can all learn from each other. This explains why the most impactful research in machine learning gets published in only a few labs, such as Google Brain, DeepMind, and OpenAI. The rise of the transformers. The past 3 years in particular, according to Mark, we've seen an unrelenting deluge of incremental work with paper titles that read like tabloid headlines. Attention is all you need. Transformers on proteins. Transformers on molecules. Transformers on images. Fast transformers. Transformers are graph neural networks. Learning to transform with transformers. Small transformers. Long transformers. He says that useful machine learning research on all datasets has essentially reduced to making transformers faster, smaller, and scale to longer sequence lengths. He says that the BERT engineer is now a full-time job. Qualifications include some bash scripting, deep knowledge of pip, waiting for the new Hugging Face model to be released, watching Yannick Lightspeed Kilcher's new transformer paper the day it comes out. I think we've all been guilty of that now, haven't we? And repeating what Yannick says at your team reading group. It's kind of like DevOps, but you get paid more. He talks about graduate student descent and the death of first principles. He's got this wonderful kind of diagram here, which he says is the algorithm of graduate student descent. Initialize, find the SOTA on archive, find the code on GitHub. If worse, make random changes. Publish. And of course, we also have this publish or perish thing going on in machine learning, which doesn't exactly help the situation. But he says that graduate student descent is one of the most reliable ways of getting state-of-the-art performance in machine learning, because it's fully parallelizable over as many graduate students or employees that your lab has. Armed with graduate student descent, you're more likely to get published or promoted than if you took on uncertain projects. Absolutely. And it doesn't help that, as Kenneth Stanley was saying, we have multiple layers of conformalization and objectives and metrics. It's very, very difficult to go against the grain and actually to follow your own gradient of interest, because probably you wouldn't be promoted if you did so. He says it's actually difficult to reason from first principles because machine learning algorithms are very complex, with huge numbers of variability and parameters where the interactions are non-linear and unpredictable. He says that ablations help, but even then, they're not entirely conclusive over such a wide range of parameters. Another thing that Mark talks about is that scale is trivial. He sometimes says that he gets the impression that academics think that transitioning to large models goes something like this. Oh, Python model.py -- super large. If only it was that easy, right? There's this kind of conception that all we need to do is just stack more layers to the neural network and it will just magically go faster and faster. He says that you need to worry about the model and data parallelism, pipelining, tuning your hyperparameters, hardware accelerators, network versus compute versus storage versus I/O bottlenecks. This is really interesting, actually. So every time I interview candidates, and I've been interviewing quite a lot of people recently, I ask them about a recent technical project that they've worked on. And the first kind of question I ask is, tell me about some of the scaling challenges. I don't think it's possible to work on any application and not have scaling challenges. You might run out of memory on the GPU, or you might be CPU bound, or you might be bound on the hard drive, or it might be latency accessing something from a blob store in a cloud. There are always scaling challenges, and if you can't passionately talk to me about what those scaling challenges are, I'm not going to give you a job. Mark also talks about fake rigor. He says that it doesn't mean that he's opposed to mathematical formalism. If anything, he loves maths and he wants to do more of it in deep learning. He just cautions against fake rigor. So he's talking about assuming certain nice properties about data so that theorems work out, gradient derivations that take up multiple pages of an appendix instead of just using automatic differentiation. He says that the worst way to do this is to simply combine complicated mathematical ideas into a neural network, because you can. You can draw on the reader's aesthetic sensibilities and discuss why Fourier is the heart of computation. The optimization community is often guilty of this, he says, where they propose activation functions like swish and then spend pages and pages talking about the nice properties of the loss landscape. He says the most reliable way to get new ideas widespread is to create a benchmark where existing SOTA methods fail and then show how your technique is better. It should be hard to displace proven ideas with unproven ideas. This technique has the advantage of not requiring any Twitter arguments. He says that it's important to avoid becoming Gary Marcus and criticize existing techniques that work without proposing any better ones which might work. I'm not sure how I feel about that. Is Gary Marcus proposing any better ideas? Don't know. Jury's out on that one. He says, where is the innovation in machine learning? Well, he says, whilst his introductory Lamont may have led you to believe that there is no innovation going on in machine learning, that we've settled on a cargo culting monoculture, nothing can be further from the truth. And he points out Keras and Fast AI. And he says here that machine learning is a language compiler and design problem. And I really love this concept myself. I'm a huge fan of Francois Chollet and Keras. And Keras is designed to be a kind of user-centric machine learning library. And it creates a very, very clear interface, and it abstracts away a lot of the vagaries and complexities of deep learning. And also it opens up deep learning for kind of software engineers. And I think that's a really good thing. I personally think machine learning should move towards more of a software engineering discipline, and we should focus on how we can create an interface and how we can decompose some of the complex components of machine learning into building blocks, and we can represent all of that process and all of that knowledge. I think that's got to be a good thing, personally. So instead of thinking about matrices or neurons, he was now thinking about layers, which is what he does when he reads a paper anyway. He also points out that performance versus abstraction is a false dichotomy. The history of computing is proof to this, right? There are many, many very powerful abstractions in computer science and software engineering that do not cost you on performance. He gives the example of Fast AI. So they have many different interfaces at different levels of abstraction. At the application layer, they've got a high-level API, they've got a mid-level API, and they've got a low-level API. Now, he also says an honourable mention to NBDev, which is Jeremy Howard's kind of Jupyter Notebook environment to overcome some of the vagaries and esoterica of Jupyter Notebook development and represent something that looks more like a software engineering process. I must admit, I'm not a fan, although I'll caveat and say I haven't spent a lot of time looking into it. All I know is that Jeremy Howard is a very smart guy. I mean, everything he does turns to gold. I love Jeremy Howard. I mean, on the notebook thing, I'm going to have to respectfully disagree with him. He also talks about the promise of deep learning is differentiable computing, or viewing kind of deep learning models as being computer programs, or maybe even viewing stochastic gradient descent as being some kind of program search. And this is what Andrej Karpathy, I think, originally referred to as software 2.0, or differentiable software. And I really like that idea. I think it's a fascinating idea. He talks about Hugging Face. He says, what is the most important machine learning company today? If you asked him the question in 2018, he would have said OpenAI. They dazzled the world with beautiful demos of agents besting expert video game players. They reminded him of why he got into machine learning in the first place. Their reputation shadowed everything, but over time, it just became their core product. He says that OpenAI is a media and service company. Just look at the pretty blog posts with beautiful typography. They force you to pay to use GPT-3. He says that OpenAI is not a platform company. He says that he can't think of a single large company where the NLP team hasn't experimented with Hugging Face. They add new transformer models within days of the paper being published. They maintain tokenizers, data sets, data loaders, NLP apps. He says that Hugging Face has created multiple layers of platforms that could each be a compelling company in their own right. Billions of dollars of value will be created from Hugging Face on problems which are a lot less speculative than AGI. He says that Hugging Face avoids the typical ML startup trap of turning into either a consulting firm or a citation farm. So at the end of the article, he leaves some parting words. He says that he's incredibly sad to see that the most exciting work in machine learning is coming from outside of machine learning. Having spent about 10 years in this field, he now learns more from crackpot outsiders on Twitter than he does from peer-reviewed papers. So he wants to hear more proposals that may probably not work, more ideas. He wants machine learning to be fun again. Some of you may have seen this article doing the rounds on Reddit just a few days ago. It's some interesting observations about machine learning publication practices from an outsider. So this person was puzzled by the amount of seemingly weak papers literally rehashing techniques from the 1980s or even the 60s and getting accepted. And he noticed the following recipe. So the first one was just the kind of cliqueiness and exclusiveness of ML conferences. He said that the group of researchers will only ever publish in machine learning conferences, not to optimization and control conferences or journals where the heart of their work might actually lie. For example, on a paper about adversarial machine learning, the entire paper was actually solving an optimization problem, but the optimization routine is basically a slight variation of other well-studied methods. He said that the peers don't know what's going on. Through open review, he found that reviewers, not just the researchers, were uninformed about their particular area and only seemed to comment on the correctness of the paper, not the novelty. And he said he doubted that the reviewers even themselves knew about the novelty of a method. Poor citation practices. He says that usually the researchers will only cite themselves or the other machine learning people, whatever that means, from the last couple of years. Occasionally there'll be one citation from hundreds of years ago, attributed to Cauchy or Newton or Fourier or Turing, etc. And then a 100-year gap to 2018 or 19. He also talks about the mathiness. Remember, there was a paper, I think, called Troubling Trends in ML Scholarship, which talked about the mathiness as being a bit of an issue. He says that frequently there'll be massive walls of math, proving some esoteric condition on the eigenvalue, or the gradient, or the Jacobian, and other curious things about their problem under esoteric assumptions. There'll be several theorems, none of which are applicable because, the moment they run on their highly non-convex deep learning application, all the conditions are violated. Hence, the only thing obtained from these intricate theorems and math walls are some faint intuition, which are violated immediately, and then nothing is said. So this person concluded by saying that ML is a sort of echo chamber where researchers are pushing through a large amount of known results, rehashed and somewhat disguised by the novelty of their problem. And these papers are getting accepted because no one can detect the lack of novelty. Or when they do detect, it's only one guy out of 3 reviewers. So make sure you check out Mark Saroufim's blog. It's at marksaraufim.medium.com, and this is where the Machine Learning, the Great Stagnation article came from. It blew up on Reddit and on Hacker News in quite a few places. He's got some strong opinions about all sorts of things, like, for example, you're doing remote work wrong. He's also been working on an ebook online called The Robot Overlord Manual, which you can access at robotoverlordmanual.com. So this manual chronicles his ambition to kind of teach himself lots of unfamiliar concepts from math to physics to machine learning. And he has a couple of principles that he wants to go by. So he hates problems with no solutions. He hates things that are too long and comprehensive. He hates sources of information that don't properly motivate the problem, things that are written by professors for professors, and once you're stuck, you're stuck. So this particular manual that he's created, chapters can be read independently, lots of illustrations, no mathematical obfuscations. It's using real-world Julia code. I'm not sure real-world and Julia belong in the same sentence, frankly, but there you go. Embraces other references, evolving, and it's free. So the table of contents here is he has a section on deep learning, reinforcement learning, physics, software design patterns, and then there's an interesting epilogue where he talks about deschooling society, so homeschooling, how to get a great job, technical books that he loves, how to read technical books, a very brief visual history of mathematics, and a beginner's guide to Dungeons and Dragons. I think there's a real art to capturing information in a way which is funny, entertaining, visual, and intuitive, and Mark has a real talent for that. Anyway, I really hope you enjoy the episode today. We've had so much fun making it. Remember to like, comment, and subscribe, and we'll see you back next week. Joining us as a guest interviewer today is Dr. Mathew Salvaris, lead principal machine learning scientist at iRobot. Previously, he was a principal data scientist lead at Microsoft for 4 years. I'm just looking through that Stagnation article. I swear you've added more to it since I last read it. It's a living, breathing article, isn't it? Keeps getting better. There's a hilarious new meme now. Have you seen the one with the Chad ML engineer?
No.
Oh, it is brilliant.
Nice.
So I'm just going to press record on my other camera and then we're good to go.
The famous other camera.
It's kind of cool with OBS how easy it's gotten. You can basically be a production studio in your bedroom.
Okay, right, we're going to go straight into it. So welcome back to the Machine Learning Street Talk YouTube channel and podcast with me, your host, Tim Scarf, and my two compadres for today, Dr. Mathew Salvaris and Yannick Lightspeed Kilcher. Today we have an incredibly special guest, Mark Saroufim. Mark recently wrote a provocative article, and reading from the article now, he spoke of machine learning researchers. He said that academics think of themselves as trailblazers, explorers, seekers of the truth. Any fundamental discovery involves a significant degree of risk. If an idea is guaranteed to work, then it moves from the realm of research to engineering. Unfortunately, this means that most research careers will invariably be failures, at least if failures are measured via objective metrics like citations. Now, Mark, you asserted in your recent Stagnation article that SOTA-chasing machine learning researchers now have their cake and eat it, taking on no monetary or intellectual risk. Provocatively, you said that they are today's medieval Catholic priests. You also said that BERT engineers can command their high salary with just basic knowledge of pip and an information diet of Yannick Kilcher's YouTube channel, much like DevOps engineers, but you get paid more money. Welcome to the show, Mark.
Thanks, it's a pleasure to be here, Tim. I appreciate it.
So why don't you tell us about this article? It was a fantastic article, and I'd love to go through some of the sections of it with you now.
Yeah, thank you. I appreciate it. So I think that the article was sort of a long time coming. Actually editing it took me about 2 days. But sort of the memes I'd been producing over a couple of months, and most of the memes independently weren't particularly popular. The article itself actually was, just was in obscurity for about 3 months after I wrote it. No one really paid too much attention to it. But as far as I was concerned, I was sort of starting to observe different incentive systems, either at my work or my peers in academia. And when I started writing them down, initially the article really started off as a rant. But what I noticed like halfway through writing it is that like it actually made me a lot more attentive to ideas that are not stagnating, like sort of what are some really interesting ideas in the field. And so it definitely made me a lot more perceptive, I think, since then, to pick up interesting stuff, but also a lot more critical when I see incentives that I just don't buy. And I think generally they're very hard to question, like because of this prestige aspect. Like one example, like I like from the article is that like I called OpenAI a media company, for example, and I think a lot of people misunderstood this point because I was actually saying two things. I was saying academia is a media business. So really, academia is not that different from a clickbait business, and that OpenAI is the single best company at doing that. And so, I would still love to, one day, like I think OpenAI is a great company. I think I've applied there a couple of times and been rejected. But still, like I do think that when I look at how much they inspired me when I was starting my ML career, to sort of now it seems like they're doing like these cool flashy demos. Like I still feel like there's something missing, that the company could have been more. And so it's sort of hard to summarize the article in a few points because I think there's been many points. But I would say like if I were to have a more like tepid title, it could have been like bad incentive systems in academia. Maybe I could have written the article in LaTeX and published it as a position paper, but I figured like the meme format was a lot more interesting to me.
I'm persona non grata at OpenAI as well, because we had Gary Marcus on here to talk about GPT-3. So that is game over for OpenAI.
Yeah, so I think the interesting thing, I actually also have like the opposite position there, where I honestly feel that a lot of people that seem to criticize OpenAI criticize it for sort of the wrong reasons. Like as in, like for me, it's like, well, it could have been a platform company, instead it's a media company. I think they could do better, and I think they probably realize this. But to say, for example, like, well, what OpenAI is doing isn't real AI because, it doesn't use connectionism or it doesn't use such and such mathematical formalisms that must be true. I find this point like borderline nonsensical because people still tell me like, well, like these techniques don't work well on existing benchmarks, to which my point is often create your own benchmarks. Like literally think of a benchmark where you feel like your techniques have a particular edge and then publish that. Otherwise, I think it's very easy to fall into the trap where you sort of like fall in love with your techniques, regardless of whether they're useful or not. And so again, I think people spend a lot of time on algorithms, and I think data sets are, I think, where people should be spending more time, especially if they want to say GPT-3 sucks. I think that's definitely a hard task to do. It's not even clear that that's like, on what time frame it's going to be wrong. But again, I think the data sets is the fastest way to go about proving OpenAI team wrong without needing to resort to Twitter flame wars.
What I found so awesome about the article is that you put in words something that many of us just know to be true, but never manage to formulate. Like you'd spout out one or two of these points every now and then, but to compress it into, look, here's like a giant problem in the ML community in words and in memes is just it's I think the success of the article is due to the fact that it instantly resonates with anyone in the field. You talked a bit right now about the incentive structures. Could you maybe give a brief summary of what are the incentive structures that you criticize and why?
So I think like historically, like if you look at like what's really the function of academia, like there was never an expectation that academics would be rich, for example. It was more like you're a nerd, like you're in love with these techniques. And academia provides like what I call like a downside hedge. Like as in, like you're not going to be on the streets even if your research doesn't work out. And, if it does work out, that's great. And then if you do this over 100 researchers, one of them is going to have a great career. The point is that on the aggregate, you're guaranteed to have one successful researcher, but at an individual level, you're not. I think instead, what's happened is that, actually one thing that I really like about machine learning is that for the maybe first time in history, the average scientist is becoming wealthy. And I think this is actually a very interesting dynamic, and one reason why you see so many physicists or biologists that are very talented going into machine learning. And I think like, great, so now not only do you have a downside hedge, you actually have a great upside. And with this great upside, you have the luxury of being able to take great risks. And instead of taking them, you're basically saying like, well, you're basically coming up with excuses as to why you can't. And so really, you should just be honest with yourself at that point and say, well, I don't really care about science. Like, I just care about having a great salary. And at that point, this is sort of like when I talk to my friends in banking, for example, they're usually very honest. They're like, I'm like, well, why are you in banking? They'll tell me, like, I love making lots of money. And I think that's a totally valid thing to say. Like, at least you're being honest. But if you say like, no, actually, I love the puzzles and I love the science, but actually your actions are saying something different. You're saying you love the money. And so there's a couple of consequences of this. I think like one of them is this sort of there's like complexity becomes a built-in feature by SOTA-chasing. Why? Like, let's say if you were to look at the BERT forks, a lot of the like Roberta, Reformer, like they're all like BERT forks. Like actually you can even see where the fork started on GitHub, which is, I think Amit Chadori has a nice article like showcasing this. So great. I mean, you have these forks and you're going to add stuff, right? And you're, let's say, add some cool stuff. You're like, oh, I'm going to add a Fourier component, or I'm going to add a CRF, or you can think of all cool sound, or I'm going to add like an energy system. So you try enough of these ideas out. One is sort of bound to work, just like by what we know by p-value hacking, which means that now if you have the compute to try lots of stuff out, you're almost guaranteed to find something that works, especially now if you take it at an aggregate level, which is like, let's say all of Google or all of Facebook is doing this, it becomes very easy to come up with something great. So now you have a new state of the art that is very difficult for people to verify. Because it's very difficult. I actually know 0 people that have ran from scratch all of the famous BERTs. Like, I know 0 of these people. I'm sure they exist somewhere, maybe like in some of the centralized language teams at larger companies like Microsoft or Facebook. But for the most part, we take these things for granted, like as in, I'll say something like long former is good for long sequences, not because I've actually ran it, just because like I've read the abstract, I've looked at Yannick's tutorial. I'm like, yeah, seems about right. Like this is like this is how it scales in the number of sequences. And so it's just become very easy. And I think as opposed to like doing science, like I think we're sort of becoming like hype chasers, almost like with a religious vibe where like, like the medieval Catholic priest reference came about because it's like, this authority said this is great, therefore this is great. And I think the sort of like first principle thinking is really going away. And I think people say like it's going away, well, because the techniques are expensive. That's why you have to trust a central authority, because you can't validate this stuff yourself. But it doesn't mean that you, like, I think this position of only, expensive ML with like lots of data, like large models, like that's the only interesting thing. I think that's sort of like just a lack of imagination, because if you look at the outskirts of ML, there's lots of interesting stuff happening, especially in the compiler space or the tooling space. The math space, there's a lot of interesting ideas going on. You just have to be willing to not be rich. And I think that's what it comes down to.
It isn't like, though, the part of the SOTA-chasing, I completely agree with you, an effect of the review system as well. So, if you send a paper in, if it beats SOTA, you're almost guaranteed to get it in. Whereas if you don't have any SOTA, or if you create your own benchmark, as you said, it's going to be very hard to kind of get that new idea in there. And, it might take you years to kind of get that idea then. And then if you're thinking about the fast pace of the way things move, that's forever in someone's scientific career.
So I think this concern can also be addressed by incentives very easily. Like, I think the way I see this addressed regarding publications is people like, well, I don't know, CC the chair of NeurIPS and be like, don't you agree that like the peer review system is broken and that it's just better to publish stuff on your own blog post? And like, what's the reviewer going to say? Probably not, like, because the reviewer has an incentive to say this structure is good. And so I think like people are asking for permission for people from authorities that they admire to say, is it okay for me to publish on my own blog post? Is it okay if it's not in this archive format that's like 8 pages long, where I have like nonsensical introductions for 3 pages? Like, is it okay that I publish that by myself? When really the answer is, it probably is, just do it and stop caring. But what happens in that case is that you have to be okay with losing out on some upside, which from an individual perspective, I often don't recommend. Like, let's say, like if you want to solve science, like, okay, like don't go work at Google. But if you're like in your early 20s and you're broke, like of course you should go work at Google. Like you should go make some FU money, get some backbone, like meet some friends. But once you have that downside hedge, like once you have that FU money, use it. Otherwise, it's not really FU money.
So very often in kind of research, one of the kind of like stepping stones is once you've moved on from a postdoc is that you have to put in a research grant, okay? And usually with your research grant, you're not going to get like from some outlandish idea. That's for tenured professors. You're going to have to do something that is kind of in vogue, and you've kind of got a new spin on it. So that generally science always moves with things that are in vogue. You can't if you spoke to the people who were doing neural networks, Jeffrey Hinton, Jan LeCun, back in the dark ages of neural networks, you would say like they kind of really avoided trying to put neural networks in kind of their grants proposals because people would just be like, nope, and kind of nope out of it. So I know we definitely have a faster pace of it in machine learning, and that's kind of the nature of machine learning because it's an empirical driven science. And so therefore it's just always about experiments. Mm. But I think it's just a general trend in science because it's just a simplification. It's how people are able to easily say, yeah, this is a good idea because everybody else is saying it's a good idea.
Yeah, so I definitely agree with you. And this is like how things are today. But let me challenge that for a second. So, like, if you were to historically look at, one of my as a teenager, I was really into German philosophers, and one of my observations at the time was like, wait a minute, like all of these guys like come from really really rich families, not like a bit rich, like sort of like fifth richest person in all of Europe kind of thing. And so I think this sort of like then tells you like, okay, great. Well, if you're rich, then you can sort of pursue this like gentleman scientist like lifestyle where you don't really care about what's in vogue or not, and you can pursue it. However, like let's say pre-internet, let's say you have like governments, for example, like controlling like how things should get funded. So you would write a grant proposal to some sort of central committee, and the central committee then needs to decide like, is this worthwhile or not? And if you look at today, for example, not only is it difficult not to get, like if you're in any field of computer science today, based on some of my peers that are doing their PhDs, they can't get funding for anything unless there's the word deep learning or neural network anywhere in there, regardless of the computer science field. Like it sort of has to be there. And this creates like sort of a monoculture, like incremental improvements. However, I think there are today many wealthy, ML researchers. And I think what you can do is instead of like, let's say appealing to the NSF, you could find someone you really admire on Twitter who's really rich, tell them like, look, this is what I'm going to do. Here's my GitHub repo. Do you mind just like paying me for rent until like I figure this out? And I would bet that this model works pretty well. And I mean, I don't have that kind of money myself, but definitely once I do, or if I do, it's definitely something I want to pursue, like a lot more strongly, because I think it's just very easy right now. And because like I can identify today many people that are 17 on GitHub that are just absolutely monstrous engineers, like 10 times better engineers than I am, even though I'm 30. But they don't live like in San Francisco. Like they live in random places. Maybe they didn't go to school, but you can see their output. Like it's very obvious. Like these people are very talented, and they don't have a good channel into academia, because then they need to like today, have already a bunch of published papers. Even though I would question like, why would you need to go do a PhD if you already have published papers? You're already a good researcher at that point. You're even more independent than most PhD students like 10 years ago. So yeah, I mean, like I definitely feel like the patronage system needs to make a comeback. And I would also encourage, like I had a recent blog post called like the sovereign student, and it's sort of like it's a spin-off of a concept I call like the sovereign researcher, as in instead of asking for permission, like start your own conference, start your own journal, start your own blog, write your own papers. Don't really care too much about what authorities care, and then just do stuff that you think is interesting and find the peers that you think would resonate with this. But if you ask the question, well, how can I make the NSF care about like my obscure functional programming library for deep learning? Well, I think that the answer is clear, like they don't care.
One thing about GitHub that reminded me of my conversation with Kenneth Stanley, and he said that we have a tyranny of objectives and we have all of this conformalization in every aspect of our lives, not just peer review in science. But GitHub actually is an example where folks can follow their own gradient of interest. They can fork any repo, they can do their own thing, and then if it looks good and other people find it interesting, then other people might fork it. I mean, it's not a patronage system, and of course these people still need to earn money somewhere, but it is actually a remarkably open-ended system, isn't it?
Mm-hmm. Absolutely. Like, I think for me, like when I think of like mastery, as in you want to become a good researcher, I think like a fairly reliable path that's a good alternative to education in general is you say, okay, well, I'm going to summarize other people's work. So let's say, for example, you start a channel like Yannick, but as a virtue of summarizing lots of stuff, eventually you understand lots of stuff, and then you meet other people that are interested in this stuff as well. So great. So now the next step is to say, okay, great. Is there like a contribution I can have here? And it's like, is there a library I can produce? And then it's like, great. Well, and eventually, well, out of one of these libraries, can one of them help me make a living? And I think of it like, well, okay, so about 3 years ago, like I left my very high paying job at Microsoft to just figure stuff out. And at the time, I didn't really know what I was going to do. I thought I would start my own company, and I sort of spent 2 years trying to figure out, I guess, what I wanted to do. And it seems like a lot, but then when I thought about it a bit more, I'm like, well, like I spent sort of 20 years in education, and I still didn't figure out what I wanted to do. And so I think like it's sort of like we never actually get that many opportunities to have self-directed exploration because we're chasing metrics, as in like I need to graduate school, I need to get a good SAT grade, I need to go to masters, I need to get a high-paying job at Microsoft. And so as a result, I think it's sort of like built in that like we don't have self-directed exploration. I think a big part of it is how long the education system is. I think it could definitely be made a lot shorter, maybe 2 hours a day instead of 8. Maybe like 4 years instead of 12. I think it'd be a lot more reasonable. I think it effectively functions like babysitting. I think that's the primary function of like of like the early education system, because parents work and they need a place to put their kids. But I think if we were honest about that, like this is the real function, maybe we would design it a bit differently. That's why I find like some of the Montessori approach like very, very interesting. And so I think this all relates to each other. Like I think we're used to having goals our whole life. And all of a sudden we're told, well, like now, if you want to be really successful, don't have goals. And that sort of creates like you're like, wait, error, like this sort of doesn't make sense. And also I think keying off of like some of the stuff Kenneth was saying, like I think it's sort of interesting because I think we're in different positions in our career. Like Kenneth is a leader at his company. So he needs to figure out like how to make other people innovative within the company. But then like his answer is also, well, I can't have goals. But then, what's the goal of a company? It's to sort of also make revenue reliably. And the best way to make revenue reliably is to also have goals and then execute on them. And so there's a sort of like friction there where I think, again, for a company, it's like, well, build cash by doing boring stuff and then use that to fund your more speculative R&D. And similarly for the individual, like make a few money as early as possible early in your career, and then use that freedom like as you get a bit older. But sort of don't get caught, I guess, like in the rat race, because you just end up optimizing for bullshit metrics.
With these kind of alternative routes you're describing, I fully applaud this, and I personally know some of these, young researchers that are just producing incredible outputs, and is very cool. But it is very much going into the direction of you have to be a media person, a media company, something like this, because now that the centralized apparatus falls away, you have to actively make other people aware of your stuff. I mean, you can produce great things and no one cares if you don't go out and be kind of like, hey, look, and so on. So where are the goods and where are the bads of this, right?
This is a great point. So like I personally think that COVID has been the single biggest opportunity in history for engineers that know how to write. Like, here's the thing, like I sort of learned this the hard way. When I left my job at Microsoft, I was trying to think, okay, well, I want to make a reinforcement learning service for game developers. Like I love games, like reinforcement learning is like why I got into ML in the first place. And so like I would like code a bunch of random shit, and then like I would reach out to random people and they'd be like who are you? Like fuck off, like, or just not answer. And at the time I wasn't that good at cold emailing people and stuff. And I had like no Twitter audience, like, like my Facebook was mostly like family and friends and stuff, like just shit posting. And so like I quickly figured out like, wait a minute, like it sort of doesn't matter that I have all this stuff. Like I don't have a way to tell people about it. And so actually late into later into my second year of doing this, I started to just sort of get like burnt out, and I was like, okay, well, let me just sort of start writing down the stuff that I learned working on my company, Yuri. And so that's how my ebook came about, Robot Overlord Manual. And a couple of my chapters went viral as well on Hacker News. And I was like, wait a minute, like this is a big deal, because now people are asking me like, oh, how do I do game AI? Do you have any recommendations? Like, do you want to work on this thing together? And so it was sort of like the marketing channel of my dreams, even though that wasn't the goal at all. It was a consolation prize because I couldn't be a billionaire from my own startup or a millionaire or whatever. So like for me, in my head, it was a mental failure, but actually ended up becoming more successful than me grinding on some code that no one really cared about. So I think that's, and so when I started writing that, initially, my first couple of chapters were what I would call cookbooks. Like they're like, here's a concept, and here's this concept explained in the simplest way possible, maybe with some accessible diagrams and accessible code. But what I realized is that like often, like the more of my personality that I would inject into the content, the more people resonated with it. And people were like, like let's say when I started like talking about like homeschooling or the modern education system, this was pre-COVID. I realized like the responses were very polarizing. Like me writing about homeschooling was the first time people got angry at me for something that I wrote. They're like, how dare you say this is the right thing? Or like, what about like, what about like if your parents can't afford homeschooling? And people got angry at me for all sorts of reasons. But what it also made me realize was that, well, like it definitely meant I resonated more with people. And so I think the Great Stagnation post was the first time that I tried to sound like myself, like for my friends that know me, like this is sort of how I talk in real life. I sort of have like these takes all the time, and this is how I view the world, is always like via incentives. And it was by far, like, I think my most successful, and polarizing. Like either people loved it or hated it. And even the people that hated it often hated it for reasons that I felt where it was like almost like a projection, where it's like, well, I'm a prompt engineer. How dare you say this is a bad thing? And I'm like, well, it's okay. You can be a prompt engineer and make some good money and then figure out some other stuff. And so I think writing for me is definitely my strongest suit. Like I'm a much better writer than I am at my other media pursuits. But it made me realize that it's good to have a process around this stuff. Like, let's say when I read papers now, I stream myself reading those papers, and then I'll have like a little edited video on YouTube. And then I get a lot of people reach out. Typically for my YouTube content, it tends to be people that are earlier in their career, starting out, learning ML. But for my written content, it tends to be more my peers. And I think it's just a reflection of how I write. Like when I write, I'm writing for myself, so it's other people like me. But when I make videos, often like in my streams, one thing I thought was hilarious was that like I'll be streaming a paper, and it's my first time reading it. But I'll still sort of figure it out, because like a lot of the math looks similar, a lot of the ideas look similar. And it's also why I think, I also get excited these days when I read papers that are different. Like by different, I mean take me more than a day to parse. So I got this, for example, with the recent paper by Facebook, like the Graph Transducer Networks paper. Like it was sort of a hard paper. Like it took me some mental, like I had to like bend my brain a bit to get it. Whereas like if I were to read a new BERT paper, often I can read it in about 30 minutes, regardless of what goes on. I don't have to understand every single detail, but just as a high level idea, like here's what happened.
Why do you think companies like Google, Facebook, Microsoft continue to finance this incentive structure? Because at the end of the day, right, they would profit the most from actually, having great scientists that do take risks and so on. And the downside, of course, of what you're saying is that nowadays you don't have to take risks. You can sort of put more compute at a problem and so on, get better state of the art. Why do these companies continue to finance this? Is it profitable, or is it a hype? Does it collapse at some point?
Yes. So I think there's sort of 2 points there. Like one, it seems to be reliably producing benefits, right? So it seems that, like, let's say if you were to think of companies like AMD or Intel, like they make their processors like incrementally better every year. That seems to be enough. Like you don't really need breakthroughs to have a sustainable business. Maybe you can just have 8% improvements year over year and still be $1 billion company. So that's totally fine. I think sort of like, I'll flip the question though and say it's not that Microsoft itself is deliberately saying, please do incremental research. What's happening instead is that as an individual, like I need to think, okay, well, like I get, evaluated on a quarterly basis or a yearly basis. I really want to get promoted, right? Like I want to make money. I want to become a manager so that like I can get more respect from my peers and be cool to maybe get poached by another company. And so if like the thing is, like if I were to do incremental research and it succeeds, great. Everyone's going to call me very smart. If I do incremental research and it fails, no one's going to tell me, well, look, what you did here was really insane. But if instead I'm like, you know what, this deep learning stuff is bullshit. Instead, I'm going to go down this like really bizarre route. And if that bizarre route likely will not yield anything, you're going to get fired. Like, I mean, it's going to be like, well, why are you here? Like, I'm just going to get the other person to take your job that produces results more reliably. So I think it's individual incentives that are sort of causing this local optimum. It's not that these companies are, it's like you said, they have the most to gain by making these techniques cheaper. Like one thing I will say though, I mean, this is maybe a bit me putting my tinfoil hat on, but like the thing is like if you're a cloud company, like you can effectively print money at this point, so you don't really care about stuff becoming cheaper. As in, like, yeah, you care about it because it makes stuff cheaper for you, but it's not like existential to your business in the same way as if you're a startup. And so I think like because the downside isn't that big a deal, like from a competitive standpoint, like you're not going to lose out that much by doing incremental work. Plus the individual incentives highly favoring incremental work means you just get lots of incremental work.
Yeah, I completely agree with you. I think it's very much driven by the individual, but also kind of these research labs in these companies are inherently just mirroring what's in academia. That's what they know. That's what they've seen as research. And the researchers from academia go into these organizations and they're like, okay, how do I incentivize? Oh, papers. Okay, papers. So how many papers you get? So therefore, it's exactly the same incentive structure. So of course, we're going to get the same kind of results. And as you said, like the people who will in these big organizations are the people who are might be more established, who are like, okay, I'm happy now. Like I know where I am. I don't care if people call me stupid if I pursue this for the next 10 years. Like if I get fired, so be it. But maybe there's something interesting at the end of it. And so it's never going to be the individual kind of starting researcher or junior researcher that's going to do this.
So I think what you're referring to is like FU money or FU reputation. It's sort of like you don't care, like you can do whatever you want and people will trust you. I just feel that a lot more people have already been in that position and not recognized it. Like if you look at a lot of top researchers making 6 figures, maybe even 7 figures in a lot of places, like they have this luxury, but then they're not really using it, to me, which feels very, very disappointing. But I guess, yeah, I mean, like incentives are too strong. Like it's very hard for you to put this brain on and say, I don't want short-term recognition from my peers. I want to work on like bizarre stuff. I think that takes a very peculiar kind of person. And I'm not sure how to sort of inject this into people's brains organically. Yeah. I think it's a very hard problem.
What's tragic about this is we know from reinforcement learning about deceptive search spaces, right? We know that we need to be going in the opposite direction of what we think is the right direction in order to solve that maze. But for some reason, we still go on the way we're doing it. We're doing something a little bit like epsilon greedy in reinforcement learning, but the big companies aren't even doing the epsilon greedy part. They're kind of socializing that for the people in their garages or smaller companies that are doing random things. And then they'll just acquire those companies as and when they do something interesting. And there is a little bit of delusion going on because the companies will say, oh, that's not true at all. We're investing in quantum and blockchain and neuromorphic computing and all this stuff. What's the deal there?
Yeah, like I think you touched on a couple of interesting points. So first, like maybe let me bash on neuromorphic computing a bit, but it's essentially to me, it's sort of like these hypotheses that are treated as fact. Like, well, of course, if I build something like the brain, it's going to be better. Maybe, like maybe not. And I even feel like one thing I tell friends is that I feel like the word neural network is sort of a misnomer. Like I like to call them matrix networks. I think that's a lot more actually representative of what actually happens. And then you get rid of like, I think this neuron analogy that I think has been for the most part holding us back. Basically here, like I call this like core porn. Like as in like, it reminds me a lot if you look at like gaming hardware, for example, we have like 12 cores or 24 cores and it's like this epic thing. But again, it's the wrong metric. Like I don't care about that. Like I care about like, can I run this at I don't know how many frames per second on this specific game. So it's really the end level metric that I care about. Or it's like, well, I care about this end level task performance. I don't care how many trillions of parameters you have. It's sort of like so tangential. But big numbers are impressive. Like, I mean, we have this bias, like we think like, wow, like that's a lot. Like, I mean, I don't even know what a trillion is. And who's to say that's a lot or a little? Like who the hell knows? It's like, why not 2 trillion? Why not 3 trillion? Like it's sort of like, so, or like, why not like a 10 million or why not 100 million? So I think like the way this is being used is that it's a successful marketing channel. And in fact, like, I mean, I don't know if you guys have observed this, like on Twitter, I get a lot of ads by Microsoft Research, which is like the most bizarre thing. And they're like advertising certain papers. And I think this is because this feeds into the brand, as in like, look, we're doing cutting edge work. Look at how great this is. We're so innovative. The numbers are going up. People in marketing love this because it's reliable. Like, it's like, I can always do a new posting like, oh, it's bigger than the last one. Like, oh my God, it's even closer to the brain than before. Like, wow. Yeah. And so I think it's just, you know, again, like, and these articles get read, the ads get clicked, people summarize them, people build off of them. So it's not like they're even being posted in a vacuum. Like people are talking about this work, they're building off of it. And so it seems to be working fine, which I think makes questioning the incentives very difficult and takes, I think, very long-term thinking. You know, which if you were to look at, let's say, like the average tenure of someone at a large tech company, which is what, like maybe 2 to 4 years or something, yeah, maybe you're not incentivized to think like 10, 20 years in the future. It's sort of, it's so irrelevant. You'd rather get like multiple quick promotions early in your career than like, I don't know, become like very, very senior and highly regarded somewhere else, get a large team. And because the field is inherently so empirical, it matters a lot. Like it's sort of like, it matters that you have 100 scientists on your team versus 10, because that's 100 more students that you can parallelize experiments over. And because there's sort of this inherent like p-hacking aspect going on, it works very reliably. And so you want to get to that point as an individual. And again, I think it takes a very peculiar kind of person to not care about that. You have to be like Gregory Perelman kind of type to not care about this stuff, which I think is a very unique character trait. Like I've met like, you know, I don't know, 2 people like him in my life. So it's not like something that I can say. A lot of people think they're like that. They're like, oh, I don't care about money. But then their actions often say very different things. So I mean, don't look at what people say, look at what they do. And what they do seems to be working fine. So they're just going to keep doing it.
Let me challenge you on this a little bit. In that, you know, you're saying something like I don't know, more parameters. I don't care how many, you know, how many transistors you have. I care about the end and so on. But something like GPT-3 was genuinely astounding. Like in the final metric of let's build something interesting, because people are now saying things like, I think what GPT-3 is doing is intelligence. I heard no one say that for GPT-2. Like, regardless of what you think about it, I heard 0 people say this of GPT-2, right? Mm-hmm. Something like DALL-E is flashy, but is also very interesting. Like, so there's definitely like some kind of interestingness appearing of SOTA-chasing, of scaling up and so on. And that is actually one of the features of deep learning, maybe.
What's really interesting about DALL-E is it gives us a lens into what's happening with GPT-3. Now, Yannick and I were desperately searching the internet trying to find all of the things that came out of GPT-3. We were convinced that this must exist somewhere on the internet. But with DALL-E, it's actually generating hamburger snails or avocado chairs or, you know, things which we know for sure don't exist. So being able to visualize that in some ways, it makes me think that, you know, as a kind of text generator, GPT-3 really is doing something quite interesting there.
By the way, like I actually agree. Like, I mean, I've said this in the Stagnation post. Like I had a memified version of Sutan's bitter lesson, which is like basically the version of the meme was you have the first year student going like hee, you know, Q learning make agent go vroom vroom. In the middle you have like sort of the researcher. It's like, well, I have to regularize the entropy in the following way, and then, you know, like the galaxy brain researcher is saying, Like most benchmarks are BS. Like the best techniques are the ones that are easiest to scale. And so I think for me, actually, because I never actually got to experience the magic of GPT-3 myself. Like I saw people posting stuff about it on Twitter. It looked really interesting. But I can talk about something that I did experience, which was playing against like OpenAI's Dota bots. And I can tell you, like, it was insane. Like I'm an avid Dota player. And I was playing against the bot, and I literally felt like a buffoon. Like I just was constantly getting outplayed, like manipulated into overextending, being like 1% of my HP before I die, and so there is something absolutely outstanding about it. I mean, it works, and it's great, and it sort of beats all the rules that you want to encode, or all the more like math that makes us like warm and comfy. Like yes. But and here's the but. It's sort of like, well, you can have two positions to this, right? You can say like, wow, this is magical. Let's keep sailing up. Like that's great. Or like, let's have more tasks that we care about. Like let's say Dota, or maybe just look at problems outside of just images or languages. Or you could say like, no, this doesn't work because it doesn't use connectionist logic. And I think this is sort of almost like a nonsensical position. The other position, which is to think like, okay, this is really interesting. What can we do besides just scaling it up? I think is also interesting, because I mean, at this point, scaling things up is, I'm not going to say it's trivial. Like it is hard. It's not like you just say Python, make model big, and that's just how it works. Like you need to think about it, how to distribute it, think about like good like paradigms for distributed compute. There's all this stuff, but this is not what I would say like generally are problems academia excels at. Like these are problems that industrial labs excel at. It's sort of like, I know how to make transistors. That's great. You can probably do that in a lab, but like, how do I make 1 billion transistors a second? That doesn't seem like an academic problem. Like that's more of a process problem, like an ops problem, right? And I think industry is usually very good at solving those kinds of problems. And so that's how I think of it. It's like GPT is a very interesting industrial problem. I just don't think of it as something interesting for academics to work on, unless they were to come up with some unique ideas that actually work, not that they think will work and just don't work. And beyond just like, I don't know, tagging along on papers where they're like, well, we make this big. And I think one thing I thought was really interesting is if you were to look at the new Switch Transformer paper, for example, like it had 3 authors, which I thought was very intriguing. And I think part of that is because like a lot of the work is reusable. Like let's say being able to scale up models, like the code's reusable, the infrastructure, the distributed dashboards, like this is a very important asset. And I think it's actually sort of the core, like that's the moat, I think, for companies like OpenAI. Like part of the moat is the people. Like they're very smart, and that's why the companies continue producing very interesting stuff. But I think another big part of that is the infrastructure is very good and is reusable. Like I highly doubt they're just running Python scripts from scratch and hacking together a bunch of open source code for the first time. Like I really doubt that's the case. So that's really my answer there. It's that from an industrial and ops standpoint, some companies are shining, but I think academics have shown a surprising lack of interesting ideas when it comes to scaling up these models.
Isn't that also because a lot of the academics are caught in these companies? And I almost feel like, maybe what's your opinion on this? A lot of times I feel like these labs in these big companies, half of it at least is just people grabbing. It's like, you're really smart. I don't want you to work for my competitor. So, go in my lab, do whatever, you like, do some BERT, and I'll pay you a lot of money. It doesn't matter what, as long as you don't work for my competitor. Is that a problem, or does that actually, I also feel it frees people up to do sometimes things because they're pretty comfortable there. But how do we incentivize that even more, these kind of interesting ideas?
Yannick and I were offered a potential job recently for an absolutely incredible amount of money to rebuild something like GPT-3 for...
I thought it was incredible, but...
It was the fat end of $1 million a year to basically recreate GPT-3. I think it was some kind of, as you write, it will give you helpful suggestions type startup. It was unbelievable.
I mean, but let me flip the question. Like, why wouldn't you take it for a year, for example? So can you walk me through your process that makes you walk away from $1 million a year? Because I think you'll probably answer your own question by answering that. Like,
Well, as I said, I've played with GPT-3. My position is the same. I think so interestingly, this particular application, the only reason it would have worked is because it's an interactive application. So there's a human in the loop. GPT-3 will only ever work for interactive applications. And even then, how the hell do you constrain this thing? It's going to literally, just depending on the words that you write, it's going to say something completely different depending on how you sample it. Keith said there's a wonderful slide he shows to all of his customers about cyborgs. So humans and AI are better than just AI. And there's an example of chess. So, if you have the human ingenuity and the chess algorithm.
Just to kind of touch about your point about Dota. So like I followed a lot of the StarCraft 2 and StarCraft 2 and StarCraft 1 were kind of my games. And I think they did a fantastic job, and kind of watching AlphaStar play was absolutely amazing. But they didn't beat any of the South Korean like top tier players. They didn't even come close. And also, if you kind of watch some of the games on YouTube, you would see that it played really well and did some amazing strategies, but it had some really big faults that, these players would just take them apart. That basically the computer would have no chance. Okay, yeah, definitely for kind of mid-tier and players like myself, it would completely destroy us. But for really, really like top tier players, it would just have no chance at all.
Isn't that just a function of how much you limit this AI? Because like the AI can always cheese you with insta reactions and so on. I know like in Dota, it was like able to insta blink, once you wanted to stun it and stuff. So I feel this is gaming AIs like this are almost beside the point, because if you just unlocked all of the capabilities of the AI, it could instantly destroy you by just microing you away, or insta reactions and stuff. So I don't know how much how interesting.
Yeah,
but I don't know how.
Yeah, and actually AlphaStar. So the AlphaStar would actually play as Protoss a lot and would basically use blink stalkers, and so precision with blink stalkers would actually destroy anything. And they did limit the APM. The precision was still too high. It was much higher than any human could possibly do it. So even if they did bake in lots of limitations, they still found that the kind of AI, let's say, or the machine learning algorithm, did kind of learn to exploit these specific things that played to its strengths. And it's not to say like, a mouse and keyboard for a human isn't the ideal input system either. So
I also saw the Blink Stalker live, and I agree with you. Like, something about it felt off. It's kind of like no human can really do this. This doesn't feel fair. For Dota, but that's not what I felt for Dota. Like, I think with Dota, I genuinely felt like this machine is a far better player than I am. I play the game a lot. Like, I'm not a pro, but I definitely have a lot of time in it. And the game did beat the best team in the world. Like, they beat OG at the time, like 2 times TI champions. And then the bot was only beaten after they publicly released it. Like, thousands of people were able to play against it, and then people found some vulnerabilities. And I think this, to me, reminds me a lot of just metas in general. So like, I've been a competitive game player for a long time, like since my childhood with chess. And it's sort of very similar. Like, when you get a new world chess champion come up, everyone studies their games, and like they'll just like study everything, and they'll know exactly how to play against them. And then the next generation of players sort of knows their strategies, knows the counters, and has to come up with new strategies. And I think something like this is very similar in that, like, maybe if you open source this thing and one time like put it out to thousands of people, some people are bound to find some exploits. But I would say the same would be true for any pro team. Like, a pro team can't actually play thousands of games versus thousands of people at once. But if it did, I think it's very plausible that a couple of players would find like some things that these players are very weak at and learn to exploit it in the same way that we would exploit machines in this regard. So I think, if anything, machines are judged more harshly than humans are in this respect.
That is related to something else you touch in your article, and namely, I'm thinking, okay, everyone can play this, everyone can figure it out, but something that you touch on in your article is this nowadays, this reliance on resources and compute and so on, where you precisely argue that not everyone can figure stuff out anymore. And yes, we could as academics go to the fringes of machine learning and do different ideas, but if we want to be engaged in the core nowadays, it seems like we have to have access to a big cluster, and Google will rent you a TPU, but it's going to cost you like 10 times as much as their internal true cost, right? So what are your comments on this? And do you see a way forward with a different incentive structure that academics can play in the main game, or should academics just kind of be creative in what problems they tackle?
So I will say like the best answer is like what Nassim Taleb calls the barbell strategy. So that means like, look, like you're gonna make good money by making birth faster or like prompting birth. So like why lose out on the opportunity? Like use I don't know like 70% of your time to just do what sort of the market wants you to do, and make good money with it. But then like use the time and freedom that you get, especially as you get older. I think this ratio should be adjusted down. So instead of doing 70% incremental stuff, start doing maybe 20%. And then this barbell strategy sort of gives you the best of both worlds, as in like, yes, your upside isn't guaranteed to be as big, but sort of in probabilistic terms, if you get like a big payoff, then you can benefit, and you're never going to be on the streets. Like you're never going to have to go, I don't know, like you're never going to be jobless. Like your skills are always going to be relevant. People are always going to understand what you're talking about. But, invest a bit. And I think it's sort of like part of what makes this advice funny is that it's not like, it's not like, I mean, it's what my grandma would say, right? It's sort of like, pursue your side hustle research and have your main job. I think that's something a lot of us can do because and there's a few reasons for it. Like one, like I have part of my meme when I talk about data scientists, like, reading papers is really an intellectual form of procrastination. I think it's like you're saying, oh, I'm working. Kinda, yeah, you are. But, you can spend all day reading papers and thinking about the nature of intelligence. Doesn't mean like anything's being produced. And so, yeah, you can do this and do a fraction of that for your day job. But use the time and luxury you have to do more interesting stuff. I think maybe also your question could be, well, how can we encourage this at a societal level? I don't have a good answer for that. Like maybe I will one day if I'm a manager myself, and I'll think about how to encourage these incentives in a team. But for now, I like to think of it like from an individual standpoint. This is a good strategy if you are interested in stuff, but you don't want to lose up on like on a guaranteed upside of a nice salary, because I think it does matter. I think you before you do anything interesting in life, like build a safety net for yourself. I think should be like it's a very obvious thing to do, but I think we over intellectualize it and forget how fundamental this aspect is.
Can I maybe amend to the question, because my question was more like, what does a PhD student at, I don't know, Atlanta University do? Like what does the professor do who isn't associated with Google? It almost seems like your path would be go to Google, make money, then do PhD. But what do researchers outside of these compute laden, money laden big boxes do?
Yes, so I will say then the best approach to get started here is to build, like summarize stuff for people and build libraries around it. So become a media company. And that way the prestige doesn't matter as much. Like the thing is, I think people don't get about prestige is that, yes, the internet has democratized stuff, but prestige still matters. Like, I mean, it's almost instinctual. Like if I look at a background and I'm like, someone went to Stanford, I'm like, probably smart, and this is very difficult for me to unlearn this because it's sort of built in. And there's a self-fulfilling prophecy here. Like if smart people think that other smart people are going to Stanford is going to have more smart people on average than other schools. So prestige matters. And if you get the luxury of going to a prestigious place, you should go, especially if you're early on in your career. That said, if you didn't get the opportunity to do this, it's not over. You have other paths, but they're trickier. And I think that the best, most reliable path for people who didn't go to prestigious institutions is to become media companies. And I think that's very feasible for people because you don't even need original ideas actually to get started. All you need to do is start summarizing stuff in an interesting way. And by virtue of doing this a lot, you're going to have more interesting ideas, meet more interesting people, and use it as an incubation period for you to build open source software. One thing I thought was really interesting. So one point I got rejected from a job I wanted. And if the feedback I got from the hiring manager was like, well, maybe you should do more open source libraries in your spare time. And I'm like, great, I'll do that. So then I started looking at open source libraries and I realized like, wait a minute, like there's really a couple of hundred people in the world that are carrying open source by themselves. Like PyTorch has like 3 people, NumPy is 2 people, Julia is maybe like 6 people. That do like 80% of the work. And so I think it's sort of an excellent ideal to strive towards, to become a popular open source library maintainer. I think it takes a long time. And my observation, at least, has been that on average, the people that I meet doing this successfully tend to be older than I expect. Like they tend to have been doing this for a long time, very persistent, and they tend to have found some way of having a downside hedge, like as in either they're independently rich, their spouse is rich, they had a startup exit early on in their career. So I think that really helps. But yeah, like I think the more downside hedge you have, the better. And once you get it, I think you want to pursue these ambitious goals, but just recognize that it's very hard just by virtue of the numbers. Like if I were to say, like, I mean, let's say you were I don't know, some sort of like nefarious country and you want to just like destroy software. There's really a couple of, maybe a few hundred people that need to be hit by a bus and you would destroy all software for like 20, 30 years. It would take a long time to recover that intellectual capital.
Yeah, no, also like I often like kind of that general idea of creating a library and maintaining it in open source on GitHub. It's a lot less visible than writing a blog post, as you said, or as you said, being a media company. Like the number of hits that you'll get on your library is just going to be so minuscule, especially if it kind of becomes quite niche. You have to make it quite general. As you said, like if it's more approachable content that's on YouTube, you get far much more engagement kind of through those kind of avenues than you do through some library on GitHub, unless it becomes huge.
It's sort of what makes me feel that like I think conferences are dead. I think this whole concept of networking is dead. I think really the internet is sort of a vehicle for nerds to meet. And I think people don't use it that way. And I think people still treat it as like, let's say, like I have a recent article where I call people LinkedIn bots. And what a LinkedIn bot is a person who has no opinions. They just share PR announcements. But instead, like, I think if you're willing to take a risk and willing to maybe be wrong or imprecise in what you say, it can end up being a lot more interesting and then attract people to you and make friends. And I think that's also one of the best ways to learn. Like, because I mean, I have a question actually, like that I ask people that, like when I was just starting out on Twitter and I was an anon, when I would ask famous people, like, what's your favorite book on topic X? I found that they answered fairly reliably, even when I was like an anon with an anime picture as my profile picture. It's just like people don't care. Like, it's a good question. I think what people really hate is like, hey, do you want to exchange notes or do you want to connect? And people sort of tense up. They're like, well, I'm busy. Like, what do you mean exchange? Like, what do you want? Like, what do you want? Like, are you asking for, are you trying to sell me something? But if you're just saying like, look, I'm interested in this really niche thing that you did. Here's why I think it's interesting. Did you think about this? Did you do this? People tend to be very responsive. And I think it's just like, it's almost like people need to become better at cold emailing people. But I think a big part of it is being interesting and valuable to the people that you're reaching out to. And it sort of flattens things. Like, I mean, if you go, let's say, work at I was early on in my career at Microsoft, it's very hierarchical. There was like 9 people for me to get to Satya if I were to jump up the hierarchy. So it doesn't, you don't necessarily feel like you could just email Satya and be like, hey, dude, like, what do you think about X? And again, I mean, you're probably not going to be able to reach out to them on LinkedIn either. But you can get pretty close. Like, I think, like, let's say I had, for example, a tweet that's sort of summarizing an interesting paper by Jan. And, he jumped on and gave some feedback about how he thinks autodiff compilers are. And I'm like, that's kind of interesting. Like, that's not something I thought was possible if I didn't have a large portfolio of papers and that Jan read my work and approved of it. Like, I can just have an interesting tweet that took me 2 hours to write because I read this paper, and then have a connection with one of the people I admire the most in the world. Like, I think that's very powerful and something that people don't use quite as much as they should.
I think it's quite difficult not to do that in a manipulative way, though. I have so many people connect with me on LinkedIn, and sometimes in the preamble on the connection, they actually say they want to sell me something. No, that's great. I can just say no straight away. And almost always that, it comes later, which means I have to put them on mute. And sometimes there are some slightly manipulative ones where they say, oh, hey, Tim, I really enjoyed your video on Kenneth Stanley the other day. By the way, I'm selling an ML DevOps product. Can I grab 15 minutes next week? And then I get about 100 messages from them.
So I think another aspect is maybe like your respective audiences have gotten large enough where you're never sure, like, are people connecting with me because they want something out of me or are they just genuinely interested in me? So I think like maybe often for like, let's say in the functional programming community that do ML, it's a very tiny community. Generally, like when people reach out to them, it's also just because there's not enough people interested in this stuff. So that can end up becoming more targeted. So I would say like find interesting people that aren't famous. It's almost like investing, right? Like try to think about who's going to be interesting in 10 years. But if you're going to look at who's investing right now, who's interesting right now, there's always this doubt in your head, and I can certainly see why you would think it's manipulative. Especially, it looks like the emails you got were very blatantly manipulative, and I would probably not respond to those either.
You quickly mentioned kind of willingness to be wrong. And I think that's a very big thing, and it's something that permeates a lot. It permeates the culture generally, not just kind of just science, but just generally people really kind of don't want to be wrong, and so therefore that makes them expose ideas that they're just regurgitating because I can't, like so and so, they're really famous and whatever, they can't possibly be wrong. But also at the same time, it means it kind of they're basking in the glow of that rightness, so to speak, without having to kind of force their own opinions out into the world and have people say, no, you're wrong. So I think that's a very interesting point.
So I learned this lesson about a year into my career, like very hard, in a very difficult way. So I was working on a BI system for ads at Microsoft. It was my very first project out of school. Like all I knew was math. And then it's just kind of like, okay, well, deal with lawyers and M&As and consultants and marketing and finance. And it was a bizarre experience for me. And I remember like there was no architecture diagram. Like all the knowledge was in people's heads. No one had written it down. And I complained about this a lot. You know, I'm like, well, I don't really understand what's going on. And the resounding feedback I got from my peers was, it's okay, you'll figure it out. Like you'll figure it out by osmosis. So what I started doing was I would start like almost like compulsively just taking notes in meetings, thinking, well, if I just do this for long enough, I will eventually figure out how this works. Until I had one of the more senior PMs on my team, who I'm honestly forever grateful for, who like looked at me while I was taking notes. He's like, are you here to take notes or make decisions? And like, I almost like teared up. Like it was just like, I felt so humiliated. But after that, the meeting, he sort of took me aside. He's like, yo, let's talk. And he like bought me coffee. And he's like, look, you know, I think a big part of this is that you're too scared to be wrong. Here's what you should do. Do an architecture diagram that's wrong and share it to everyone who works with you and tell them this is how things work, right? And then they're going to tell you, of course not. Like this is wrong in the following way. So he taught me very early on that like, look, share the wrong thing and people will correct you. And it's something I've experienced over and over again. Like at some point, I wrote an article about Lagrangian physics, Lagrangian mechanics, which is sort of this optimization way of doing physics. Like you minimize an energy landscape. And I'm not a physicist. I'm an ML person. And the feedback I got from a lot of people was like, I shared it on Hacker News. It was pretty well ranked there. And I had many physicists that were like, look, you made it something and you said something incorrect here. You should have said this instead. Here, no, this is a mistake. You're coding the wrong reference. This doesn't make sense. And I would just say, thank you. And I would fix it. And I'd be very grateful to those people and share them the feedback. And obviously, if people are trolls, you know, they go like, well, like, how dare you as a machine learning person do physics? I just go kind of like, and I would also respond in a trollish way to just be like, you know, like don't mess with me kind of thing. But when people were willing to give me candid feedback, I was very grateful for it. And I think it's sort of, like again, like I do the same thing now with my videos. Like I'll say wrong things, and I'm like, wait a minute, like I'll figure out how everything works out, like in the 50th minute of my video, and then I'm like, okay, great, I just need to scrap this whole thing, and now I can explain it. So I don't know why people have this bias. I think maybe it's school to like, I don't know why, like perhaps it's school and grades and stuff, but yeah.
I can understand it a little bit. I have it myself that I want to be polished and I want to understand things and I want to iterate on things. And I quite often used to say when I was younger, let's not be busy idiots. Let's be really smart about this and figure out what we're doing. But there's something to be said for just getting something out there as quickly as possible. You know, doing something crappy fast can be better because the kind of feedback that you get from that diverse audience out there is actually going to be far better than anything you could have done on your own.
Mm-hmm. And it also, for me, sort of nullifies the benefits of peer review. Like, I think the internet, you can sort of self-select your peers. I don't actually know any physicists in my day-to-day life that could help me give me feedback on a post about Lagrangian mechanics. I know a lot of people that I just know them by their usernames, that happily give me long-form feedback, which is insane to me. Like these people exist. And I think part of it is that I've realized a lot that even though like ML is very popular, the amount of people that have interesting and original thoughts about it is very small. And so like you'd just be surprised. Like, I mean, even MLs is huge, popular. Physics maybe is even less popular. But these people exist and they're willing to give feedback as long as you're also interesting. And it also makes this point around, like, let's say I like a lot of people, and I was guilty of this when I was first starting Twitter. It's like, I would tweet something and then tag Nassim Taleb pretty much on every single one of my posts. And like looking back, it's like the cringiest thing, because like I'm looking for approval for someone that I really admire. And I think just getting rid of this and being like, look, no, I think it's probably interesting. Like, let me just post it. If people want to think it's interesting, they'll like it. Instead of being like a sort of like an incel about it and blaming other people for why you're not interesting, like figure out how to be more interesting. And I think it's a worthwhile pursuit. Like,
you said something really interesting a second ago, which is that you think very few people in the ML community are actually really driving the innovation. And I just wondered, what do you think is the distribution of talent, and what does that mean? Because we were saying earlier, quite cynically, that there's not much talent. We're all SOTA-chasing, and we're just doing incremental improvements, and we're doing the you called it the student gradient descent, didn't you?
Graduate student descent, yeah.
That's right. And in Silicon Valley in particular, which I think is very near to where you are, there's this mindset when hiring software engineers that if they can't do coding challenges and don't know about data structures, then they're crap, and there's this prevailing mindset that only 1 in 100 software engineers are any good. Do you have the same opinion about machine learning? Do you think there's like a few really good engineers and everyone else is not very good?
Yeah, like I will say that there's lots of engineers, but I would say easily less than 1% of people in ML. Probably I would say maybe even closer to 0.1%. So I think there's just like inherent power laws. And I think like the thing is about power laws is that they're inherently uncomfortable because they don't give a good distribution of outcome to people. However, it's a function like, look, like your attention is a finite resource, right? Like you can read any paper you want. So you're going to naturally direct this attention towards a small fraction of it. And we're all going to be basically reading the same papers by the same people doing really interesting stuff. That doesn't mean that there's always like, the heretics, at the outskirts doing stuff that seems totally insane, but is totally interesting. That's why, like, I mean, I have this concept that I call like a sovereign researcher, which is a researcher that, just does things by themselves. I think one really important thing that a sovereign researcher should do is help crackpots flesh out their ideas. Like, I think that's like, like, it's like make them more precise. Don't just be like, oh, you're a crackpot. Like, be like, what is it really that is turning this from an interesting thing to a non-interesting thing? And I think like you also mentioned the point on interviews. I actually recently wrote a new blog post on like the myth, what I call like the myth of objective text screens. And I actually detail in very painful detail a lot of my personal text screens. And basically how they effectively work as rubrics. Like, it's sort of like, I ask you a bunch of questions, like, what's the best, what's the best loss function? Well, like it depends. Or like, can you do this? Or do you know what YOLO is? And I'm like, well, I know what ResNet is and UNet. And I think I can figure out YOLO. It's like, but do you really know what YOLO is? I'm like, no. Like, yes or no? Like, I'm like, well, no. And so I think like there's this aspect where, if we're just going to be interviewing people by rubrics, what ends up happening is that you effectively test for stress. It's like how good were you at sort of doing the SAT, at like reading a bunch of top concepts in ML and doing them. Whereas I think like really to sort of get to the more interesting parts of tech interviews, I think inherently they need to be more subjective. And by subjective, I don't mean do I like you? It means tell me sort of about like your proudest project. And let's talk about it a lot. Like, let's talk about like why you find this exciting. This is unfortunately very subjective, but to me, it gives me a sense of like, does this person like have a spark in their eye? Like, do they care about this stuff? Like, do they care about making it better? Or do they just sort of do what their manager wanted them to do? Which I think is unfortunately very common. Like, it's like either my manager told me to do this or Google told me that I should be doing this. So always looking for an authority to get permission to do stuff is just generally, I think, very widespread. And I think it's just shockingly painful how few people don't do that.
Could I play devil's advocate on that? So let's say Google and Facebook, they do have a very calibrated interview process. And they do that on purpose because they want their process to be scalable, replicable, calibrated basically, so that they'll ask you the same questions and they'll formalize exactly what answers they should have. And they design the questions in such a way that even if you knew what the questions were in advance, they're testing your understanding. and they're testing your communication skills and so on and so forth. Now, I can come up with some fairly good examples for software engineering, but perhaps Mark and Mathew, what kind of interview questions do you ask during machine learning?
Actually, so obviously I like always the basics, just understanding, and I always try to probe where their strengths are. So looking at what they've done in the past, and also kind of just figuring out by getting them to answer questions that should be what they should know. But beyond that, to Mark's point, one of my favorite questions is I always try to leave time at the end and said, is there a paper or a set of papers that you find really interesting? And why is that interesting? And what is it? Because exactly to Mark's point is if they're really interested in doing the research, if they will have this, they will find papers, they will be excited about something that might not be mainstream, especially like they get extra marks if it's definitely not mainstream. And because it shows that they're willing to go out there and pick these pieces of information together and invest the time in going through the papers, and not being, so the kind of common term is armchair scientists, where they're basically just reading papers and never doing anything. But they're not kind of just armchair scientists. They're kind of trying to draw threads together and go, okay, I think it should be this, and this are the experiments I would do. They could be complete failures. And if they did the experiments and they were complete failure, great. But you did something, you thought it through, and you thought how you could move things forward. And I think for a scientist and a researcher, I think that's really, really key. Yes, they need to know the basics. Yes, they need to be able to do or whatever they need to do, but they need to be able to kind of think outside the box and think how they could possibly extend things.
So to sort of key off of that, I 100% agree in that for me, I don't particularly care about weaknesses. I think they're sort of overrated. Like I'm really trying to figure out like what is this person good at? What do they care about? And so I think like Richard Hamming had a good question for that, which is like sort of what's the most important problem in science and why aren't you working on it? I think this can be adapted for as an interview format, which is like, let's assume that you could work on this dream problem of yours. Walk me through it. Like, how does this work technically? How do you make money off of it? Like how do you know that it's getting better? Like what could be some issues that you could foresee? Well, what about memory? What about speed? So sort of like pick a very specific niche problem that I know the other person is interested in because I asked them what they think is the most interesting, and then just tackle it from all parameters. My worst interviews were the ones that are like, have you heard of technology X? Have you heard of technology Y? Those are just very bizarre because I mean, like, it's sort of like I don't spend my day just surveying technologies all day. Like, I think if you are, that kind of sucks too. You should find better stuff to do in your time. But I think the interview process sort of actually encourages that. That said, a lot of it can be gamified. Like actually when people tell me like, oh, how should I prep for an ML interview? There's a book called the 100-page ML book that I think is great. And then maybe the, Data Science from Scratch by Joel Gross, also another great book. Speed read those books and then go on Google, like, okay, see what is a transformer? What is a ResNet? You'll probably pass, a fairly average like data science interview just that way in a couple of days.
Could I gently challenge that, Mark? Because you said you've got your Chad ML engineer meme. And one of the things on there is that, you basically say that reading papers is intellectual masturbation. You say, procrastinates all day reading papers. But you do advocate, you just said, like the 100-page ML book, and you've got a wonderful list of books. So where do you draw the line between intellectual masturbation and actually, useful reading online?
Yeah, so I think it's all about ratios, right? Like as in like if like I think people get into tutorial hell very easily in ML. It's like, how do I do CNN, mass RCNN? How do I do YOLO? Okay, how do I do transformer from scratch? And then they just like end up in this tutorial hell. Or they just end up reading all the basics. And then it's like, well, you could spend like maybe 30 years reading the basics and you'll never be done. And so I just think of it as, again, it's sort of like an explore exploit paradigm where you running the stuff yourself, you'll very quickly learn stuff like, wait a minute, like these loss functions don't work very well. Oh, like these optimizers work better. I really need this dashboard. Oh my God, early stopping is very useful. Oh, mixed precision is great to make this faster, but it makes my loss like diverge. So the first principle aspect is so important. And because the field is so empirical, it's sort of like your core, like this is your moat, like this is your personal moat, like your set of knowledge is not what you've read in tutorials. It's like the personal experiences you've had from failed experiments and successful experiments. So getting a large body of experiments, I think, is very important. And then, of course, again, this goes back to the barbell analogy. Like when you are reading random stuff, like, go crazy. Like you have the luxury of reading whatever the hell you want. So why not read the interesting stuff? For example, like when I left my job, I had this long list of books that you're referring to, Tim, and a lot of it did feel like intellectual masturbation until I started summarizing them. Then it became something real. Like then it's like, oh, wait a minute. Like now I have the only, like let's say I wrote a tutorial about automatic differentiation. It's now like the top entry on Google if you Google for automatic differentiation. So it's something I was very proud of because I mean, yeah, lots of tutorials existed. They were all very dense. They had lots of math, or they explained it in a too high level a way. So turning from something from a thing that I know to an asset that just grows while I'm sleeping was one of the biggest achievements for me, like the biggest realizations that I had like in the past year, and it's totally changed how I work. Like it's like I try to have as much of what I do be publicly facing because it makes it better, and it turns it into useful assets for me. So I don't read, like I often rewatch my videos or my tutorials at this point because I'm like, oh, how does this thing work? I'm like, oh wait, I'm like, this is pretty good, like I feel pretty, or I'm like, well, this is actually garbage, I need to edit it, which is why like I do frequently re-edit my documents. I don't treat them as this thing that I just do and never look at again. Like even my list of books, I change it every month or so. There's a new book that comes in or comes out of that list. So,
but it seems to help you having it all online. It makes you accountable.
Yes.
Because at the end of the day, this is self-directed learning, and I'm very impressed with your passion and your energy. And I have it as well in a sense, but I'm running this YouTube channel, so I have to be interviewing people every single week and keep on top of it. Would it be the same if you were just completely on your own? Would you still be self-directing your learning at the same pace?
I mean, like it doesn't have to be a hypothetical. It's what I actually did for 2 years between Microsoft and my current job at GraphCore. I don't think it's for everyone. Like I think it's basically you have amazing ups where you're like, oh, I'm a god, like I did this by myself, but then you're like, you get really bummed out and you're like, oh, why am I doing this? Like my friends are getting promoted, they're making a lot of money, I don't have millions of dollars yet. So I think like it's very hard day to day because you don't have like a tap on the shoulder telling you good job or that was good, Mark, good for you. However, sharing it online gives you a shortcut. So now, like, I mean, as soon as I started doing that, I don't care about people giving me pats on the shoulder anymore. It's so irrelevant. Like, I know that when I write something, whether it's good or bad. In fact, like, let's say in my post, like the stagnation post, I wrote it 3 months ago, and I actually had a live stream where I was writing it live, and I was telling the people who were watching in, it's like, I told them, like, I'm pretty sure this is going to be a popular post. Like, I sort of knew deep down this was better than other stuff that I wrote. Because I just am honest with myself. Or other times when I'll write a post, I'm like, well, this is a cute post. It's not gonna, blow people's mind. It's interesting. It's okay. Like I'll post it. And so generally, like I know, like I trust my gut feeling more. And I think like again, but I wouldn't have been able to just be on my own for 2 years had I not had a really nice salary at Microsoft. So again, I think this idea of a safety net really matters because it gives you more options. Like you don't have to use them, but you can. And I think a lot of people just don't. They just sort of settle into a very local optimum where they're like, oh, I don't like my job, I don't like my team, I don't like the city, and then they just like are very fatalistic. Like I met so many depressed people my age when I worked at Microsoft, and it's just kind of like. I think it almost felt like I get it, like I resonate with it, but at the same time, to me, it often felt like a lack of imagination. As in, well, you don't have a girlfriend, you hate your job, you don't have friends, you don't have hobbies. Like you're probably gonna be depressed. Like it's okay. So take some actions that let you do more interesting stuff in your day-to-day life, and you probably won't be depressed. And I think sharing stuff online is a good way to do that. Again, it's a good shortcut for a lot of these things.
I mean, with respect to sharing your stuff online, I want to challenge you a bit there as well, because I started my YouTube channel in 2013. When I really started uploading my first videos, I think in 2017 or so, and no one cared. Like it was, even though it was new, it was the first. Like paper explain channels did not exist, and now there is even like copycats, right?
Yeah.
Like one copycats, which is. And a huge honor, honestly, but it did not exist. And for years, no one cared. And I just sort of uploaded it as a procrastination for myself because, I thought, maybe it'll help someone. And it seems like it's a bit of a bigger problem because most people, when you say you have to become a media company, you have to become a media person and so on, most people just, due to that Pareto law, aren't going to succeed. Like how many... And people are trying to game this now, right? People are trying to like write Medium tutorials where you just know this is written, so kind of their
They're
online
cookbooks.
presence and so on, and they suck, right?
Yes,
A lot
they do
of them.
suck.
It's like Clubhouse, right? Like not everyone is interesting. Yeah. Let me rephrase that.
100%, yeah.
Everyone has interesting things to tell, but just just doing a big conversation where everyone puts their opinion out there, that's not interesting. So
Okay.
everyone sort of has to find their own niche, yes, but I feel this whole media thing, it doesn't work out for most people. Or do you see that differently?
So inherently, you're right. Like, I think what you're referring to is attention is finite. So you get these Pareto distributions where, like your channel has like what, 70,000 followers, mine has 400. So there's like sort of a big gap where it's like, well, there's some people in the middle, but it takes time because a lot of people would just, let's say, rather just watch the more polished one. And there's a feedback loop because as you do more, you get more accountable, you get more feedback, you get better, so there's just like so many feedback loops that mean that the more popular content is often actually better. But I think that people have tried to game it in a way that's very lazy, and this is what I call like the cookbook tutorials. As in, like, let's say I read a chapter from some author, like let's say you read the Chris Bishop book, you read a chapter, and then you'll just basically put it in a Medium article, and you're like, great, this is how, like, multilinear Gaussian, and it's very obvious, like you're not in this field, like you have nothing to contribute. You're like, why are you doing this? However, I think that's why being more genuine is interesting. Like, let's say in my case, for example, like, am I as famous as Gary Marcus? Like, probably not. Am I one of the most widely cited, like, OpenAI researchers? Like, also probably not. But I think what worked about my post is that it was written in a way that I hadn't seen other people write, because I deliberately made it sound like me. Like, this is how I talk. Like, I swear all the time. I make fun of shit all the time. But I also love science. So it's maybe it's not that unique of a Venn diagram. But, combine that with people that enjoy writing, all of a sudden, like, I'm one of the few people producing content that's like this. And it resonated with people. And so I would say often it's very scary, but sounding like yourself is very important. And okay, so great. So now you're like, well, I have an expertise like ML. So now how do you sound like yourself? I think the best way to do it is to copy authors you like. And so the authors that I admire the most are Nassim Taleb, George Orwell, and Chuck Palahniuk. They all have like this irreverent style that they write in. It's all like satire, but talking about the real world. Then Talib actually has like math, so it's like also kind of mathy. And so initially you're like, oh, I like this. Like, why do I like it? Well, I like it because it resonates with me. So you copy it, and then by sort of jumbling them all together, you sort of end up with your own unique voice. And similarly to your memes, like let's say in all of your cases, like you make jokes, you make memes, you could have tried to sound like Jan, but you're not Jan. Let's be real. Like, Jan is more accomplished, more successful, more contributions to the field. So if you were to compete with him directly there, you're going to lose out. Like, Jan's going to capture most of the attention. But like, well, let's say Jan doesn't produce that many memes. He's not interested in doing videos. So instead of trying to be the best at one thing, try to be the best at a whole cross section of stuff. And you're likely to be the only person competing with yourself in that case. And so that's why I think for this post, like, let's say when I think about my cookbook articles, I can definitely see competition, as in, oh, like, here's this other automatic differentiation tutorial. Is it better than mine? Whereas with my stagnation post, I know I don't have competition because I don't know anyone else that sounds like this. Like, I don't know any other ML article. I know a few actually that have memes, but not to this extent, and not like as, I guess, as critical. And so it makes me comfortable to have found my niche. I think more people can do it. And if anything, I feel that, one of the most common questions I get asked after, should I do a PhD or not, is, how can I become a better writer? And so I tell people, step one, write. Step two, try to sound like people, right? Like, tell me about the authors that you like. And if you don't have any of those, then it's very hard. But again, like, let's say you may like a fantastical style of writing, like sort of dreamy, like, well, you can combine that with ML. That's sort of a unique thing. You could talk about ML in a very historical way, like, looking through the history. That's also very interesting. You could talk about it from a systems perspective. That's also very interesting. And, these are all very obvious. Like, these people exist. Like, I can think of people that have a cross section between systems and ML. I can't think of many accomplished writers that have this cross section of skills. So maybe in 10 years, it will be more crowded, but I don't think we're there yet. I think people just haven't been writing enough about their own unique experiences yet. And I try to encourage people to do it more because I feel like I found my voice. Like maybe it's sort of like this, again, like I said, like this irreverent style, being critical, sharing way more personal detail than I'm generally comfortable sharing. But what I've generally found is historically, I did stand-up comedy. I also did like a lot of my friends' wedding speeches. It's often the jokes that I really wanted to take out that were by far the most successful, where I'm like, should I say this? This is a bit much. Like, I shouldn't make this kind of joke. Or like maybe people get angry at me here. And then when I keep those end up becoming the most successful. My latest article on interviews was like this because it's very personal. Like, I mean, I literally shared about like 15 different stories of me being told like, you suck at ML and software. But it ended up becoming very popular among a lot of people I shared it with because they're like, oh, like I felt this, you know? So it's like, great. Well, if you all felt this, like no one wrote about it. I only see people on Glassdoor talking about like, oh, I made $500,000 at Facebook. Like, you know, you don't have the other people saying like the more, giving a more interesting take on what may have happened or reflecting on their own personal failures or reflecting on maybe the failures of the people the failures interviewing them. So again, I think we're nowhere near saturation.
You say that you kind of like Nassim Taleb, like reading your articles. I got that. I could tell that you definitely either have read quite a bit or you do like him as an author. So it definitely comes through.
Thank you. Yeah, I mean, for me, that's the biggest. That's one of the biggest compliments you can give me. So thank you. Appreciate it.
Yeah, I do like some of his books, definitely.
And what you said before really resonated with me as well. I think being yourself and finding yourself, with Yannick as well, you know, he is his unvarnished self on YouTube. He doesn't edit anything, and over time I've been learning to edit less and less. And at the beginning I would edit out many things that I say that actually are my character and are me. And I think the art is, it takes a long time to find yourself online, but when you do find yourself, just present yourself as you are, and that's actually what people like.
I sort of think of it like the hero's journey. It's like you're a Link and you're looking for like the master sword. I think it's very similar, but I think people don't undergo the journey to try to find themselves, and they just end up in local optimums. But yeah, I think I'll end on that.
Indeed. Well, Mark Saroufim, it's been an absolute pleasure. Thank you for joining us this evening.
Tim, Yannick, Mathew, thank you so much. It was a real pleasure. Appreciate your time.
Thank you. Pleasure.
Remember to like, comment, and subscribe. We love reading your comments. And we'll see you back next week.